Okay, think about this for a second. What if you could build an AI not just to, write your emails or make some cool art, but to actually tackle the biggest scientific mysteries of our time? Well, today we're diving into a brand new model that's trying to do exactly that.
So, on one side of the ring, you've got the most powerful artificial intelligence humanity has ever created. And on the other side, well, you've got our biggest scientific challenges curing diseases, discovering new materials, understanding our own planet. You'd think this would be a match made in heaven, right?
But yeah, there's a problem. There's this huge gap between all of AI's potential and how it's actually being used in the lab. So what's getting in the way?
The issue really comes down to something we can call AI's scientific divide. And this gets right to the heart of it, the idea of a black box. See, the most powerful, the most state-of-the-art AI models, they're proprietary. Their code is a secret, how they work is hidden, and access is super tightly controlled by the big companies that built them. Yeah, we're talking about the heavyweights, the absolute Goliaths of the AI world. Models like Google's Gemini, the latest from OpenAI, and xAI's Grok. I mean, they're incredibly capable for sure, but they're not open for scientists to actually look under the hood, to customize, or to build on for their own specialized research. And the consequence of that is pretty simple. When the best tools are locked away in a vault, it just slows down discovery for everyone else. It's like trying to invent the future with one hand tied behind your back. But what if a new challenger stepped into the arena? One that was designed from the ground up to just shatter that bottleneck. So meet Intern S1. Now, the keywords you gotta remember here are open source and scientific data. This is not your average general-purpose chatbot. Nope. This is a specialized genius, built from day one to speak the language of science and to share its brain with the world freely. So to build a scientific genius, you gotta send it to school. A really, really big school. This number, 2.5 trillion, that's how many tokens or little pieces of information from scientific papers and textbooks and data sets that Intern S1 was trained on. It's a mind-bogglingly huge library of human knowledge. Okay, but that's the big question, isn't it? How can an open source model even hope to compete with these corporate giants? Well, turns out Intern S1 has a couple of secret weapons up its sleeve. First off, it's multimodal. Now, that's just a fancy way of saying it has multiple senses. It can read text, obviously, but it can also see images, like microscope photos. It can understand the 3D structure of a molecule, and it can analyze data that changes over time, like seismic waves. You see, science isn't just words on a page, and neither is this AI. You know the saying, you are what you eat? Well, it's the same for AI. And Intern S1 was fed a very, very specific diet. This wasn't just, scraping the entire internet full of cat videos and bad opinions. This chart gives us a peek at its curriculum. You can see this heavy, heavy focus on core scientific fields. It's got deep expertise in life sciences, which is crucial for drug discovery, material science for creating brand new technologies, and physics to help understand the universe. This thing is a specialist. All right, its second weapon is, honestly, even more clever. Science has its own unique language, right? It's full of formulas, symbols, and special notations that can totally confuse standard AI models. So Intern S1 has this custom-built translator just for this language. It's called a dynamic tokenizer. So think of it this way. Instead of seeing a complex chemical formula as just a random jumble of letters and numbers, this tool helps the model actually see the molecule's structure and its meaning. And the result of this is just staggering. It means it can process and understand really dense scientific information up to 70% more efficiently. That's a massive, massive performance boost. Okay, so we've got a model that's been trained on all the right stuff, and it has the right tools for the job. But, talk is cheap. How does it actually perform when you put it to the test against the best in the world? This really is the multi-trillion token question. Did our open source challenger actually manage to land a punch? The answer is a resounding yes. Just look where Intern S1 lands on this benchmark. See that dot right there? It's right up in the top right quadrant, hanging out with the closed source giants. And it's the top performing open source model in its class. It didn't just compete, it basically joined the elite club. I mean, closing the gap is one thing, but winning? That's another story entirely. So let's zoom in on a few of the head-to-head matchups. This table tells an amazing story. On ChemBench, that's a test of chemistry knowledge, it scores higher than both Gemini Pro and OpenAI's model. Then, on SFE, a test for scientific fact-checking, it wins again. And on an Earth science exam, yep, it comes out on top once more. This isn't just keeping up anymore. This is leading the pack in some really key areas.
But what does all this actually mean? Beyond the numbers and the charts, why does an open source model winning these benchmarks matter so much?
Because at the end of the day, it's not really about the score. It's about access. By making a model this powerful open source, it puts a world-class AI tool directly into the hands of any researcher at any university, any institution, anywhere in the world for free. It completely levels the playing field for discovery. And this is the ultimate goal, stated right there in the team's own paper. It's not about just building the best AI. It's about building a foundation that helps thousands of other scientists make their own breakthroughs way faster.
And this leaves us with one final and I think crucial question. Now that a tool like this is open to everyone, the only real limit is our imagination. So what problem would you solve with an open source scientific genius?